Let's talk about network design considerations in the campus for both wired and wireless LANs. So let's suppose that we have a client down here, client PC, that needs to connect to the Wi-Fi. This has a lot of different considerations. We're not going to focus too much on the RF aspect, which when we say RF, coverage, interference, from external things, channel overlap, and things like that. These would all be covered by a Wi-Fi survey. So we're not going to dwell too much on any of that just now. What I would like to talk about is when a PC wants to connect to the Wi-Fi, normally an access point, what are the onward considerations that we want to think about? So let's build this up a little bit at a time. An access point is going to connect to a switch. And a switch will have a VLAN or VLANs configured on this link or this port. If this is the port that I just drew in, on that interface is likely to be a trunk port with multiple VLANs that are mapped to different SSIDs. So that switch, one of the first considerations that you would like to make is that a layer 2 or a layer 3 switch. The physical ports on this switch also need to be considered in respect to they will need PoE or PoE plus, and there's UPoE, which all have different reasons for being chosen in the campus LAN design, but they all have an impact on cost as to how much this switch is going to cost. But let's just say this is the access layer switch. In most campuses, if they're not doing software-defined LAN, this will just be a layer 2 access switch. So this access layer switch will typically connect to a core switch, and the core switch is normally layer 3 with, let's just say, that is a default gateway, and this client is on VLAN 10. Now, some considerations here, even just on the layer 3 switch, will be routing protocol, so is that static or BGP or OSPF? Typically this direction to, well, I'll just connect it to site router. Site router. And that site router can be SD-WAN, it could be just a traditional router, it could be a firewall, whatever, but ultimately it goes to the wide area network. Now this is important. The reason that the WAN is important is because actually this access point down here might talk to a wireless LAN controller that's up here in the data center. So let's say here there's a WLC, and I'm going to have to mark things up a little bit here. Maybe move this stuff up here a bit. But let's just say that this access point effectively creates a tunnel to this wireless LAN controller, and config, monitoring are all performed on this wireless LAN controller on behalf of this access point times, let's say, 600 APs at this site, this remote site. So you can see that we're building up like quite a bit of a few different components here, that decisions that you make around what type of PoE, PoE plus, UPoE, if this is a layer 2 or a layer 3 switch. This interface here is this MGig, so multi-gigabit Ethernet. So for example, you might want to future-proof your network by putting in multi-gigabit Ethernet switches that support 1, 2.5, 5 and 10 gig copper connections. So typically what that would look like on a switch is, if you've got like a 24 port switch, 2, 3, 4, 5, 6, 7, 8, 9, 10. So if that's a 24 port switch, then it might just be this subset of ports which are MGig and can support 1, 2.5, 5 and 10 gig. And then you connect a super duper AP that has 1/2.5 gig capability, but it will auto negotiate on the switch port. So a long story short, these MGig switches will cost more and it will put the cost up, but if it improves the performance, then it might be negligible in regards to improving business performance. So you might need a high performing WLAN, and in that case then the investment is worthwhile. So after we build this picture up, the wireless LAN controller is located in the data center or somewhere. The next thing that we probably need to think about is authentication. So authentication can either be done on the wireless LAN controller, where you configure accounts, user accounts, but that's not manageable because you might have hundreds of wireless controllers. Let's say that there's 50 wireless controllers. So creating user accounts on the wireless controller probably isn't a feasible thing. So what you might do is implement what we call a radius server. Radius. And that's normally like Cisco ICE or FortiNAC or something like that, Forti Authenticator. There's ClearPass from HP and various other solutions that can be used for Radius. And again, you can configure this Radius server to have user accounts and then apply policy. So the idea is, if you were to then create a user account for me, Malcolm Boudin, I would log in from this PC with my username and password, and all the way up this chain my authentication request would end up here at the Radius server, and then once it gets there, it can either authenticate me if the username and password is, and the user account is stored locally on there, manually configured, or it can integrate with an Active Directory server or identity provider such as Azure or G Suite, and then use my network login credentials to validate who I am. And that might be my username, my password, my machine, and result in giving me a certificate, which is effectively a key to the kingdom in order to get authenticated onto the network. After you're authenticated, a policy is applied to this user account, and the policy might be equals VLAN. I can't remember what I said. 10. And then from VLAN 10, I'm only allowed to access certain things. The key considerations with this particular video, I wanted to highlight the complexity in building any end-to-end network. This is just a very simple example of building out a wireless connectivity mechanism end-to-end from a site and a PC down here to authenticating against all this stuff here, whilst also considering switch types, which increase the cost, depending if you go mgig, PoE, UPoE, PoE plus. If your ports are in all these different speeds, if you just need 1 gig ports, the determining factor might be, the uplinks. So this uplink between the access and the core might be 10 or 40 gig or 10, 40 gig. And we're sometimes even seeing 100 gigabit per second uplinks between different layers of the network. That summarises this particular video. It was really just a little scribble because it was something that I was working on today, and it got me thinking that networks are getting really complex, and the requirements from customers is always to reduce the cost. So it's trying to balance out the requirements versus keeping the cost down can be quite tricky. Hope you enjoyed the video.